Hi. I wanted to start by taking you on a journey. So going from Christchurch to Sydney, then Sydney to Dubai, and then Dubai to Nairobi. And that whole journey takes about 32 hours once you factor in the layovers. And of course, Nairobi is the capital of Kenya. And when we arrive in Nairobi, we then want to go to this small town called Mbita. Now, to get to Mbita, you can either fly to Kisumu, which is the nearest big city to Mbita, and then it takes about 2.5 hours to travel to Mbita by road. Or you can go the long way and travel by road from Nairobi to Mbita. And in Kenya, you drive on the left side of the road, but when the roads are not that great, you drive on whatever side of the road works best. It takes about 8 or 9 hours to reach Mbita. And you arrive at this field station for the International Centre of Insect Physiology and Ecology. And it's a beautiful campus. It's where we lived and worked for a number of years. But just by the way, if you don't enter the gate and you look around Mbita, you see quite a different space. It's a very, very different way of life. And it's a fishing town. It's right on the shore of Lake Victoria. It's like a completely different world. And I've gone on such an effort to go to this different world, gone to travel all that way for a spider that would comfortably fit on my pinky fingernail. And my pinky fingernail is not big. It is a child-sized pinky fingernail. So we're talking about something that's really little. And you might be thinking, why would you do that? Why would you go all that way when there is a country called Australia, which is right next to New Zealand, and Australia's got all these spiders? And even like in New Zealand, we've got around 2,000 species of spider, and something like over 90% of those species are endemic to New Zealand or only found here. So we've got our own very special spider treasures here. But, just out of curiosity, who here likes spiders? Yeah? Is it a few of you? Yeah? It's interesting because when I ask a room of children who like spiders, I get this reaction. They're so excited, and there's usually like maybe one or two who go, but then the rest of the children, they make them excited too, but yeah. But anyway, would any of you like spiders more if you knew that they targeted mosquitoes? Would there anyone? Yeah? Yeah, see, that makes it easier to sort of justify an interest in spiders because, mosquitoes. And if we go back to Africa, my mother was born in Zambia, and she nearly died of malaria when she was 2 years old. And so although I grew up in New Zealand, I was very much aware of just, the dangers of some mosquitoes. And of course, malaria can kill like hundreds of thousands of people each year. So for me, learning about a spider that actually prefers to eat mosquitoes, that was quite personal for me. And when I learned about it, I just had to know more about it. And so that's what actually got me into spiders in the first place. Now, what that spider has in common with these spiders, now the spiders on this slide, they're all found in New Zealand. Now what these spiders all have in common is that they are all jumping spiders. They're from the family Salticidae. This is the largest family of spiders. There's over 6,000 species of jumping spider found throughout the world. They're not found in Antarctica, but they're found pretty much everywhere else. There's even a species that's found on Mount Everest. And regardless of where you are in the world, the way that you can tell that you've found a jumping spider is simply by looking at a spider and seeing if it looks back at you with these two big eyes at the front. So they've got this remarkable eyesight. They've got 8 eyes. They've got 6 of these smaller eyes, which are the secondary eyes, which mainly function as motion detectors. But it's these 2 big eyes at the front called the principal eyes, which have been of a lot more interest to us because these are the eyes that enable the spider to see objects in its day-to-day life. And most jumping spiders don't build webs. Instead, they hunt for their prey like tiny cats. So what they do is when they see their prey, they start stalking it. They move very slowly. And then at the right moment, they pounce and they grab, kill, and eat their prey. And they've got such good eyesight that they take this well-aimed leap to their prey. Now, this mosquito-eating spider, its name is Ivaca culicivora. Culicivora is an interesting name because it basically means eats mosquitoes. Vora means to eat. Culica refers to mosquitoes. But it's not just that they're into mosquitoes, because what they really want is the blood inside of the mosquitoes. Yeah, no. And so, as far as we know, this is the only species that specialises at feeding indirectly on vertebrate blood. So they're not actual vampires. Be pleased to know they can't bite us directly. They're too small, their fangs are too small. But to get their blood meals, they go after the mosquitoes. Now, a spider like this, it needs a nickname. So for as long as we've been working with them, we've been calling them the mosquito terminator, because just like Arnold Schwarzenegger, these tiny predators are on tiny missions to seek and destroy, in this case mosquitoes. Now, because jumping spiders can see so well, what you can do is present them with different types of prey and look at what types of prey they prefer more than others. There are different ways you can do that. So, one obvious way is by just giving them live prey and see which ones they attack first. Or what you can do is get a dead prey item, glue it into a lifelike posture onto a piece of cork, and the jumping spider will respond to that as though it's living prey. Or jumping spiders can watch television, and so you can present them with animated prey and look at what prey they attack on the screen. And consistently, they go after the blood-carrying mosquitoes about 90% of the time, even when the alternative is a mosquito that isn't carrying blood. But although they can see so well, their sense of smell is also very good. So this is like a bird's eye view of a Y-shaped olfactometer. So what you can do, you can put say 20 blood-carrying mosquitoes in one chamber and another type of insect in the other chamber. The spider begins the trial in this Y maze, and it can wander up, and when it reaches this junction, it can either go left or right. Now, it can't see the prey at any point during the experiment, but again, they go for the odour of the blood-carrying mosquitoes about 90% of the time. Another type of testing is this retention testing. It's different. So instead of presenting them with 2 odour sources, now you present them with 1 odour source at a time. So again, for instance, you might put like 20 blood-carrying mosquitoes inside this chamber, and then you put the spider inside this little chamber, and what you're looking at is how long they spend inside that chamber before they start just sort of wandering away and into this other chamber. And again, they're spending significantly longer near the odour of the blood-carrying mosquitoes. This is what they really want to eat. Now, before I continue, I just wanted to introduce you to a couple of the people who I've worked with in Kenya. So this is Professor Robert Jackson, who is the person responsible for getting me into spiders in the first place. So what Nicole mentioned was that I used to really not like spiders at all. But Robert, when he told us about spiders in lectures, it just opened my eyes and just showed me how interesting they really were. And he's the one who made the discoveries about these mosquito terminators. And so he came back to New Zealand all excited. He was telling me about these spiders, and then I told him about the family connection to Africa, and it's like, then it just sort of started from there. And so he helped me to get to Kenya for a number of years. This is Stephen Alowich, who is our head technician in Kenya, and Stephen is amazing. He's so good at finding the spiders that we need for our work, for looking after the spiders, for helping us run the experiments. So all of this work, it just couldn't be done without Stephen. Now, the pictures of these mosquito terminators that I've been showing you so far, they've all been of these adult males. Now, the adult males, they've got these little red faces. They're so adorable. And the females are mainly brown. Now, they do have a slight reddish tinge to their faces, but they are mainly brown. But the thing is, it's not just that they're going after mosquitoes for dietary reasons. Both the males and the females are interested in blood-carrying mosquitoes, and part of the reason why is that when they're fed on this prey, they start to smell more attractive to the opposite sex. So it's like they pick up this blood perfume. And it's like, so we've published this work in the Proceedings of the National Academy of Science. And when we got it published, New Scientist really got into this, and they created this cartoon. But one of the reasons why they got into this was because we actually had to change the title of our paper, and they wrote this little article, and they were saying, why did you change? Because we originally had blood as perfume in the title, and we changed it to this really sort of bland title, like, what was it? How blood-derived odour influences the mate choice decisions by a mosquito-eating predator. And they said, what happened? And the reality is we just had to do what we had to do to get this work published. But anyway, so the blood-carrying mosquitoes matter a great deal to the adults. And you know how I showed you that male on my pinky fingernail? So both the males and the females, they're only about 5 millimeters in body length, so they're a little spider. The baby spiders are, of course, even smaller. And so when these hatch, they basically resemble a dot with 8 legs. They are the size of nothing. And you would think that such a tiny spider couldn't possibly bring down a mosquito, but you'd be wrong. And so the thing is, so this is Anopheles gambiae. So this is the mosquito that's notorious for transmitting human malaria. And so the way that they transmit malaria is by biting an infected person, and then they go and bite another person, and then they transmit the malaria parasite, the plasmodium, to this uninfected person, and then they get malaria. This mosquito is biting my hand, And I took that photo as it was biting my hand, but it was safe for it to bite me because it was reared in the laboratory and had never bitten anyone before. But the reason why I've shown you Anopheles is that Anopheles is actually preferred by these tiny spiderlings. You can't see it in this photo, but the thing about Anopheles is that they tend to rest with their abdomens tilted up. Other mosquitoes rest with their abdomens sort of parallel to the substrate, but not Anopheles. And what happens is that this posture gives the tiny spiderling just enough space to creep underneath the mosquito, leap up, grab the mosquito with its tiny fangs, and even when the mosquito starts flying away, this tiny spiderling can hang on with its tiny fangs, and it has just enough venom to bring that mosquito down, and then it's in for the feast of its life. So, of course, in Kenya, our lives were sort of absorbed with these sort of tiny animals. But, of course, in Kenya, it's famous for its big animals, its big mammals and birds and reptiles. And of course, some scientists are very fortunate. They get to work with these animals. They get to work in these really lovely field sites like Tsavo East or Amboseli. They might work with these big predators. And of course, we work with these little predators like the mosquito terminator. Now, we don't really get to work in these sort of more glamorous field sites. Our field sites are different because our field sites are walls, and you see all sorts of action and adventure on these walls. And this is how discoveries like of the mosquito terminator can be found, because you just look at these walls and you might see this particular spider eating a particular type of prey more than other types of prey, and then you go and you learn more about it. But another thing is that one thing about the mosquito terminator was that we were finding them around places where people are found. So we were finding them around our houses. We were finding them around schools and around hospital buildings. And it got us thinking, because here we have a spider that likes mosquitoes. The mosquitoes like people. That's what's known as being anthropophilic. Like, for instance, human odour is very attractive to Anopheles mosquitoes. So you've got spiders that like mosquitoes. The mosquitoes like people. Maybe the spiders like people as well. And there is one very quick and convenient way of testing for attraction to human odour, and that is by presenting the animal with previously worn socks. And so this kind of work had been done with mosquitoes in Kenya. And so what we did was we got the same man. He was anonymous. I don't know who he was. So he wore the socks for the mosquitoes. We got him to wear the socks for the spiders. And he wore the socks for 12 hours. He even wore his shoes while he slept to make the socks as stinky as possible. And then he gave us his socks the next morning, and then we gave that odour to the spiders. And what we found was that both the males and the females, they spent significantly more time near that odour of the previously worn socks as opposed to socks that had never been worn. Now, this is the first evidence of a spider being anthropophilic. And so, thing is, yes, they love these blood-carrying mosquitoes. They're very attractive to the odour of these mosquitoes. But it might not be a particularly easy prey to find. But if you find yourself around people, then that might then increase your chances of finding the prey that you really want. So Yes, Africa. It's an amazing place. Yeah, it's like another world. And within that world, there are all these other little worlds. And yet, we've got these little worlds around us everywhere, like even in our own backyards. What worlds are we walking past every day? And what discoveries could we be making? What discoveries are there right under our noses? I just wanted to leave you with that sort of lingering thought, because, spiders are cool. I wondered if anyone had any questions.
Kia ora. So do you primarily catch the spiders, or do you breed them? And if you do breed them, how do you go about handling them?
Oh, how do you breed spiders?
Yeah.
Oh, yeah. I have to say, when I first started working with these spiders, we had a quarantine lab in Christchurch, and Robert brought some of these spiders here. And it was actually my job to mate the spiders and look at their courtship behaviour. And this is my first time working with spiders. I didn't know what to expect. So the males do little dances, but when they mated, I was really quite disturbed because I didn't realise that they use their mouth parts. And so I tried to separate them. And then I thought, hang on a minute, the female isn't running away from the male. So I thought, okay, just risk it, see what happens. And sure enough, they were mating, and that's how I learned how spiders mate. So we do both. We both, like when we're in Kenya, we both capture them in the field and we mate them. And it's just quite typical sort of spider procedures. You sort of rear the spiderlings up to adulthood. And it is really helpful to rear the spiders up to adulthood, because then you know what experiences the spiders have had as they're growing up. And so a lot of the experiments that we do with these spiders, it involves the first time they've ever seen a blood-carrying mosquito, and yet they show that very sort of marked preference for that prey. So, yeah.
There was something in your biography about psychology department. What's the link?
Yeah, so I first began as a psychology student, and then I was very much interested in cognition, animal cognition and behaviour. And then Robert taught me into biology, and then I've worked there, but I've moved back to psychology, and a lot of my work now, it's still involving animal cognition, and it was kind of hard because when I was trying to decide what talk to give tonight, I thought, oh no, I have to show you these mosquito predators because they're really cool. But I would love to, if you want me back, I will come back and talk to you about spider cognition at some point, because I would do it. Yep. I'd be all for it. They are so cool. What they can do with their tiny brains, it could keep you awake at night. It's so be very happy to talk about it.
Anyone else have a question? It's pretty cool that these spiders can target malaria-carrying mosquitoes. Do you think they could be used practically to help protect against the disease in any way?
Yeah, it's a really interesting question about whether they could be used to sort of help with the fight against malaria. And the thing is, some people have asked us if we could breed these spiders in the millions and then release them. And of course, you don't want to do that because, you don't know what sort of impacts that have on other environments. But we sort of think about it as being like malaria's like this big jigsaw puzzle, and these spiders might just be one little piece in the puzzle, but they're out in the environment for free, and we just figured why not learn more about them. And those connections, like to the mosquitoes and to people, it just, to us, that makes it such a special little spider. And we just sort of, when we were living in Kenya, we just had to learn as much as we could. And it was mainly about educating and just trying to tell people that spiders are actually really good and you should encourage them into your houses. Because honestly, when I see these spiders in my flat in Kenya, it just partly warms my heart, but also it just makes me feel good to know that it's there. And I just, yeah.
Fantastic. That's all we have time for now. But thank you so much, Fiona. Everyone give a round of applause.